Teresa. Hello, everyone. Thanks for coming to my session. There are a few things I can talk about. First thing is OpenClaw. Second thing is GitHub Copilot. Then last bit is how I can build apps on my mobile phone while dropping off my kids to different classes during the weekend. And I found it very helpful to me. So in this case, you can see I have a pump. In the end, it created a game like that. It's as simple as you just put your idea into your Telegram in this case. Then my backend OpenClaw GitHub Copilot is going to be building all the apps for me, then deploy that actually to an Azure website. Then I can test it out myself. So in the end, with that prompt, it's one short prompt. My teams of agents from Mushroom Kingdom will help me build app. The idea of Mushroom Kingdom is from my boy because he likes all the games from Mario. And then you have a game up and running like that. So I'm going to show you how I did that. And I will also show you how I can use the same concept to building some of POCs for my customers. So let's take a look. First thing, a quick introduction of myself. My name is Daniel Fang. I'm from Microsoft, and my role is solution engineer. So one thing I do on a daily basis is talking to my customer. And a lot of customers say, I had enough with your slides. I want to see something up and running. I want to build a POC. Then I tell them, are you going to pay for the POC? They say, no, I want to see it first. So that's one of the problems I try to solve for myself. If I have a tool to help me build something very easily, at least conceptually it will work. That will help me a lot doing my day-to-day work. And the second part for me is out of work, I spend a lot of time with my kids' robotics team. They like some coding. They're interested in building something themselves. So that's some experience I want to share with you because I had quite good fun with my boy building using the same concept, some games like the one you saw earlier. So even a 7-year-old, 8-year-old kids, if they have some idea, type their idea into the app, see what OpenClaw and GitHub Copilot can build for you. All right, so what I'm going to talk about in the next 30 minutes, very simple. I will explain why I want to do that. Then let's start with we engage the OpenClaw agent very simply via Telegram. It's like a chatbot. We take a look how we can deploy and save the token cost. Is there a few ways you can set up for yourself? Then we start with building a very simple web page. Okay? We talk about how you can optimize the token usage, the run cost. Then finally take a look at my agent team. We have a developer, a QA, a DevOps engineer, and also a dev lead there. Finally, let's run an end-to-end. An end-to-end POC, it runs for about 2 hours, but in the end, it builds some app for me, deploy to Azure, deploy to Foundry. It's end-to-end working. So let's take a look how it works. First thing, I'm going to explain why. So my weekend is so busy, drop my kids to different classes on the weekend, swimming, taekwondo. So I'm on the move all the time. Don't get a break on the weekend. And sometimes on the weekend, you really have some good ideas you want to build and see it come up with. And that is what I did in the end. So while on the mobile phone, that's my phone. It's split screen. I have my Telegram there. I can talk to my agents. That's the session I'm waiting for my boy to finish swimming class. It's like 2-3 hours over there. If I have some idea, I type into my Telegram. The Telegram engaged agent in the backend, then start building. And when I finish the lesson, go home, I can check. And that's the taekwondo class. Again, I'm doing the same thing. I have my GitHub mobile app. I have my Telegram. They keep on building for me. And when I get home, I can run everything end-to-end, making sure it works. If it does not work, I can go back to my Telegram agent and say, improve it. Something not working out. Do it better. Things like that. It's quite fun to see how the agent is able to do for us. All right, so let's move on. First thing, how do we get started? In my case, what I did is I have a monthly Microsoft Azure subscription credits every month, $220. So I thought, let me deploy all the resources to Azure. It's a Windows VM on Azure, and then I install the OpenClaw onto the VM so that it can run. It looks like that in the end in the VM. It's a standard OpenClaw control plan. You can do the settings, engage your agents there. You can connect your OpenClaw agent with Telegram or WhatsApp. So there are quite a few integration options you can do. All right, so let's take a look how it looks like. So first step is fairly simple. I have my Telegram on the left-hand side. I have my team of agents sits there. And then that window is the console window inside the VM, how the OpenClaw really runs. I start with a very simple question saying, hey there, it's very simple, a chatbot, right? Then my first agent, Mario agent, that is my assistant, he will look at my question and start to respond. And after a few seconds, Mario said, all right, hi Dan. You probably wonder how does the agent know my name? Because there's a few setup steps. You will have provide some information to the OpenClaw agent so it knows who you are. And you can also ask questions about who are you. The agent also have souls, have a few definitions you provide and define what agent can do or you don't want to do. Then the agent responds, I'm the OpenClaw assistant. I can do things to help you. Then ask OpenClaw, what can you do? And the chatbot said, I can do a few things, right? And the good thing with the OpenClaw agent is it do have a memory. It will remember what you have discussed with the agent before. And we also have a few shortcuts saying status. Then the OpenClaw agent will say how many tokens I have used and a few things, running stats, and all the conversation history, etc. You can have a few options you can integrate. Then I ask the agent what I have been talking about lately. That's a test to see if the agent remember what I've been talking about. And you can see the agent now searching the memory, saying, let's look at the history. What did we talk in the last week? What are the topics around? So the agent will look through the memory and provide a summary saying, we have been talking about the weather, we have been talking about a few setup on Azure, and that's all from the agent memory. Okay, so that's very simple. We have one agent up and running in OpenClaw. It remembers what you have been talking and having conversation with the agent. That's a good start. Then on the right-hand side, that's the console window of OpenClaw. Every single time you interact in the main window, the command really runs on the VM. And it will also call out to Foundry to use the models, or you can connect with the GitHub Copilot for the kind of different cloud model, etc. So that's our first to start with. It can go on. It can do quite a few things over there. But let's start to make it a little bit more complex. I want to show you how we can integrate the OpenClaw with GitHub Copilot. All right? Because GitHub Copilot itself is a cloud agent. It can run different development tasks by itself. Let's take a look at our second demo. So this one is the same. I have my agent that's told, my developer agent. That agent have access to GitHub Copilot. What it can do is, if you wanted to do something, rather than the OpenClaw agent do everything itself, it will create a ticket in GitHub, assign that ticket to GitHub Copilot, and let the GitHub side agent to work on it. The benefit of that is you can create multiple tickets at the same time. They assign to multiple cloud agents from GitHub. It will speed up all things. So far, I have asked a question. I wanted to build something, build a pack page, and you can see the OpenClaw agent has engaged a few things. On the right-hand side, a session by the GitHub Copilot cloud agent has started. It starts to build the app, start to look at what's the requirement, start to check the code into repo, and also do a test. All the things happening on the right-hand side is controlled by the OpenClaw agent. All I did as a human is asking a question about what I want to build. And as you can see, the GitHub agent is building things. You can also add follow-up questions. Say, I want to change the direction. I want to give additional instructions to the agent. All right. Then the OpenClaw agent will be watching and keep on polling how the GitHub agent is doing. And once everything finished, you can see we have a draft PR ready to go on github.com. And we have a pending review item. I'm not clicking anything. And you watch very quickly, the OpenClaw agent has approved the PR. It will also carry out the merge of the PR. It's all carried out via the GitHub CLI. The OpenClaw agent has access to that repo. Then everything is merged, draft branch is merged. Now we have our commit into the main branch. You can see there are two simple files has been created under the pack folder. That's what I asked to do. It's a very simple web page. Okay? And it did not stop here, because my agent now will report back to me to say, all right, the GitHub coding agent has finished the work. That's a summary of it, and that's the link to the repo. You can do a verification yourself. All right? Simple. We can ask both agents to working together, and you can also integrate all other sorts of agents with the OpenClaw agent in a similar way. Let's take a look at what actually is happening under the hood. You now know we can talk to the agent, OpenClaw agent. We can ask OpenClaw agent to engage other agent. Under the hood, everything happens in the VM. The OpenClaw is do all the work for us. So in this case, that's the VM deployed to Azure. When you start the VM, the OpenClaw service will run in the backend. So you can see it's a boot sequence. It will load each of the agent one by one. It will load all the instruction file, load the memory, load the soul file. Then the agent will be ready to go. When you ask a question in Telegram, it will basically route into the OpenClaw service, and it will respond. That is how the OpenClaw control panel looks like. You have a few tabs. You can take a look what are the overall usage of your token, how many sessions are running. Each time agent is running, you can see the details interaction. What is it doing? Then we also have a list of agents you can define. In my case, I define about 4 or 5 different agents. They can work with me together. Then let's look at the backend. What is there under the hood? We have a number of files inside the file system. It starts with a number of files. You can configure what are the token usage. Each of the agents will have its own isolated folder. It can work on, write the code, and have access to. Then in the OpenClaw.json file, this is where all the main configuration happens. I have a number of token providers, models. I have a number of agents, definition configured. And then on the right-hand side, you can even use GitHub Copilot to help you define these definitions. Sometimes the JSON file is not easiest to work with. And then on the left-hand side, I have a few folders for each agent. This agent will share a folder with all the definition files. It is able to use these files to understand how each of the projects are tracking. Because my idea is using the agent to build the POCs. When it's trying to build the POCs, it will create a project file. Each new idea goes into a markdown file. This markdown file will track what the project is about. It has some solution design. It has some brainstorming, the app definition, how it should build out. And then I also define all my workflows because I have multiple agents. I want this agent to follow a process I like when it's trying to build out. For example, start with do the development, then do the QA, do the DevOps, to do deployment, then finally test them end to end. In that workflow file, I have roles. Toad captain is dev lead. I have a toad that's developer. Toadette is the QA. Then also have Yoshi as the DevOps engineer. Each of the agents, I have particular roles for them. For example, orchestrator does not do work. The developer should write the code and do initial testing. We have the QA role is try to run the app from end to end, use browser to do the test. Then finally, DevOps is try to deploy all the apps into the cloud. Basically, I want everything to run from end to end. I don't want to do anything. I want to verify the end product in the end. Then very importantly, all these agents do share a few files. Because they are building in the same project, they need to know what other agent is up to so it can continue building and understand the catch and then keep on building out. There are a number of processes I have defined for the apps. Start with, you need to use a Git repo to start with. I want all the source code to be version controlled. Then it will define all the project structure and blah, blah, blah. That's a lot of stuff I have manually put them in. That's the process I want the agent to follow. So that when it's built, it's most efficient rather than the agent that need to keep your thinking and working things out. All right, keep going. So let's take a look. Now we have the agent. We have looked at how the setup we have in the OpenClaw service. Let's build something simple to start with. So again, Telegram on the left-hand side. Right-hand side is the OpenClaw terminal window. So let's take a look at the agent I have. So I have the Yoshi DevOps engineer, Toadette QA dev, and that's the dev lead. Let's start the question and ask it to build a game for us, a simple game. So how I do it is, I ask the Toad, our developer agent, try to start build something in the OpenClaw. So it has finished the build, and it will actually run the browser session to test it out. It's a very simple game, but you can see the dev agent, it does not only write code, it compiles, try to run that for real in the browser, and test it out. You can see the game is up and running. And once the build is done, in the Telegram side, the agent actually report back to me to say, oh, I have finished the build. Now I'm going to hand over the session into our Toadette, which is our QA. The QA agent will do the same thing, do the testing from end to end, see there are any bugs, fix them up. And when the QA agent is happy, everything is done, it hand off to our Yoshi DevOps engineer. Yoshi will take care of deployment. So run the bicep deployment, deploy the application. In the end, you should have a live URL available on Azure. And you can go in and play with it. That is how the OpenClaw session looks like under the hood. You can see the agents are engaged. It tries to do different actions. And then once everything is done, it does a screenshot for me saying that's the end product. It also gives me a URL. That's a live URL on Azure. And then one can click on it and test it out. And once it's hosted, it looks like that. It's a very simple game. So now I can play the game, see if I like the design, if I want to make the game harder, etc. You can go back to the agent and say, improve this game, add more level to it, things of that. And very simple because you can do everything on your mobile phone. Okay? So far, we are good. We have built something very simple. And you can see, start with dev, QA, deployment, different agents, they are working together. And as the human, we test the end product in the end. And we can keep on iterate, build more in the same way. One issue I ran into very quickly is the token usage, right? Because I have Azure VM. VM are not cheap. Plus, I need to have all the tokens applied to the agent so they can keep on building. Some of the session runs 1 hour, 2 hours. The token cost is so high. My monthly free credit used up very quickly. So I have some idea. What if I just turn off the VM at night time? Then every morning when I'm ready to use it, I will restart everything. That is what I did next to optimize the cost. So what I did is I will use still our agent over there on the mobile phone. I set up a GitHub Action pipeline. That pipeline will, every morning, when I wanted to do, start the VM, set up all the resources. For example, I have my app service. I have a number of integration service. I will manually start it every morning. That means at the nighttime, everything is shut down. And that's a way to expand the usage. You can see once I ask it to start, the Mario agent is able to give me some response back saying, I have started VM. I then ask the agent to say, now please use that skill. The skill is something you can build for your Copilot, the OpenClaw agent. The agent will be able to follow the instruction in the skill, try to start my DevOps and Azure resources. So you can see I said Claw setup skill, the agent start to look at the skill file. And then on the right-hand side, the agent on the VM start to look at the instruction inside the skill, try to run it. And in this case, it just invoke GitHub Actions, and will watch the action to finish, and then report back to me, say, everything is ready to go. So you can see there's a pipeline already running. So it's trying to run the pipeline. And then in here, very quickly, it will give you a few links saying that's the GitHub action I have invoked. And then the OpenClaw will have a backend process. Keep on monitoring the processing. Is that done? Is that done? And you can see the action has been invoked. And if you go to the link, you can see when GitHub action is actually running in progress. It starts to run the bicep to start up all my app service and integration service. And once everything done, the agent will come back to me to say, all right, you're ready to go. You can start building. So I try to do that one. So I can save some token. I don't have all the resources running at the nighttime. And during the daytime, I can use the same token and the resource for more build. All right. So now everything you can see is finished, almost finished. The OpenClaw agent will just report back to me, say everything is ready to go. So it's very easy because when for me on the weekend, I'm doing all sorts of other things. I don't have to sitting next to the computer. And I did the same thing with all other agents. A few agents can help me look at my calendar, see is there any important meeting coming up. I have also other agents can help me like watch mailbox, things like that. That's good. Now we have a few agents working. One important thing next is, how am I able to have an agent team working together? And that is our Mushroom Kingdom agents. So we have a few agents I've mentioned. The first one is Captain Toad. That's the dev team lead. It's like an orchestrator. So the role is take command from me and then engage all the sub-agents to do the development, right? Then we also have our second agent, the Toad, developer. Third agent is Toad at QA. Yoshi is the one doing the deployment. Let's take a look how we can put everything together end to end. In this case, it's still a fairly simple thing. What I do is go into the OpenClaw console. I'm able to define each of the agent roles. I will start with the captain. So the captain, you have a few things you need to define. You have the agent definition markdown. You have the soul. You have a few other things you can fill in. The instruction I have here is very simple. I tell the Captain Toad, this is the working folder, and what are the skills, tools you can use. Then I will define souls. I say you are the team lead. Your role is to orchestrate, but not actually doing the work. I also ask the agent to see, look at the workflow markdown I have defined, making sure all the instructions are put into the workflow you need to follow, especially as the leader. Then you can keep on adding more instruction in the same file. This file will always be loaded by OpenClaw each time the session starts. So you have a very persistent instruction always be known to the agent. The same thing, I look at our Toad. The Toad is a developer, so I have a very simple instruction on top in the soul file saying, you are a developer, you need to code, you need to do initial testing. Then similar, if you look at Toad, that same thing, you are QA, Your role is to do the testing end-to-end. I've made it very explicitly, not just the unit test, but you need to run the application, do the UI testing end-to-end. Then same thing, we also have the skill files. So there's a number of default skill files. When you install OpenClaw, it enables for you. But in my case, I'm building apps on Azure. So I have loaded all the Azure skills into the OpenClaw in the same way. So it knows how to deploy app service, how to deploy different integration service. Okay? I have all my agents ready to go. That's good. Now the big question is, does that work? Does that work for me to build something really end-to-end, like a POC for my customer? How long does that take? So that's my next demo. That's a long demo. It took me about 2 hours to do the recording, but it does able to build something end-to-end from a one-turn kind of pump for me. So let's take a look how that works. All right. Again, left-hand side is my Telegram, and right-hand side is the VM. Let's see what I do. So I will start with writing up my project. The POC I wanted the agent to do. It's just some write-up. It's very simple, not in detail. I will also provide some reference so the agent is able to utilize. I paste all my instruction into Telegram, send that to the captain, the orchestrator. The captain now says, all right, I got your request. Let's start building. But before it passes on to the developer agent, it will try to understand what needs to be done. It will create a project file for each POC, add some technical details before it hand over to our Toad agent. In this case, you can see on the right-hand side, it's very busy. The OpenClaw has a lot of things happen. It will generate the files, do the definitions, and we can also see a developer session has engaged. So the first agent it runs is the Toad agent. The Toad agent will look at the project details, understand what the dev work needs to be done. It will start building. And when the agent builds, it is not just writing code. It will also try to compile, try to see if code is not working, there are bugs inside the code. It will also try to engage the session, see the app in the browser in a similar way. You can see it's going good. It has done a few things. I think it already passed all the work to Toadette, the QA, because the dev work is done. If you look at the other session channel I have here, all the sub-agents actually are talking to each other. I have 2 channels. One channel is for the orchestrators, don't need the details. The other channel is all the interaction between the agents. So in this case, you can see Toad has finished the work, saying, I have done my dev work. Let's engage the Toadette. Toadette received the command from the Toad saying, that's the repo, that's the source code. Please run it and do the end-to-end testing. Toadette says, I got it. Now let's build. So it will carry on, look at all the initial project details, look at the repo, compile, and actually run the session for real in the browser, right? Click a button, test out different actions, and it will capture a screenshot for me. Imagine I'm just picking my boy from a class. I can quickly look at the screenshot, see how the progress goes. If I don't like a screenshot, I can quickly engage the agent and say, I don't like the design, do some rework. Okay, so it's good. Now the Toadette QA has finished all the testing. Things looking good. It's going to next step. Let's now hand off all the work to our Yoshi, DevOps engineer. The role of Yoshi is create bicep. We need to deploy all the Azure resource, app service, backend, Foundry resource, agent, etc. It also needs to deploy the application code. And in this case, what Yoshi doing is it's using GitHub Actions, try to have all the action file defined, try to deploy the Azure resource first, and it will do the app development. So on the right-hand side, you can see it running the deployment. I'm playing that like 16 times. That's very fast. But in the end of the day, we have an app running on Azure. That URL is no longer a localhost URL. It is an Azure resource URL. Basically, everyone on the internet can click on a link and play with it. All right? And it did not stop there, because the Toadette and Yoshi should give me a final update. It will tell my orchestrator saying all the dev work is done. And this is the final product. You can see in here, Yoshi already said I have finished all the work. This is how the app looks like when it's hosted on Azure. It's a quick screenshot for me to verify if it looks OK or not. All right? So if you keep on watching, what will happen next is the session in OpenClaw will finish. Our captain, the captain gets the update from all the sub-agents. Now it says the work is done. All the sub-agents have completed the work. I also have a URL for you. You can go there and do a test. And that's what I do. On my mobile phone, I start to click on a link. You can see a POC app is already built. And although it has some issue because the button runs very fast, that's an indication of the backend service may not really be running correctly, but that's okay. I will fix that in a tick. Let's go back to how many tokens we have used. In this case, I have got a few models, GPT 5.4, and I spent about $78 on tokens that day. I built about 3-4 different POC. And I go back. As I said earlier, feels like everything is running, but I know the button runs too fast. Things is not working out. The reason is it is trying to run everything in the test mode, offline mode. Basically, the agent built the app. The app does not really work because it runs into some issue. I told the captain, it's not good enough. I do not want a mock. I want you to test out everything end-to-end for real. Everything needs to work, right? And the captain agreed with me, saying, all right, you are correct. Let's now send back the whole dev work back to my team of agents again. Start with Toad. Let's do the redev. Figure out why the app is running in offline mode. The Toad look at all the code. It figure out, all right, there are some mistakes I have made. Some app step is not done correctly. Toad start to go back to the same repo, pick up where the error is, try to fix them up. And then they found out the issue and fixed the bug. And interestingly, the next time is this Toad does not pass on the work to Toad to do QA. It actually engage the Yoshi to do the deployment. And that is a very important step because now we will deploy the fix to the cloud. Then the QA can happen on the real URL rather than it's a local test. And in this case, Toad look at the newly fixed version. It looks all good. A new screenshot is attached. It looks more complete than before, and I'm able to use the same URL to the testing myself and see if I'm happy with it. And if we look at the application again, the live application again, all the buttons are working. It has a few screens. It actually engages a Foundry agent and the portal to do analysis of emails. It has a few different screens. The screens have charts, has summarization of the email, has some analysis all built in under the hood, right? And that's the tab. So that is what I found quite interesting. Allows me to really build something, some idea I have on the move, maybe on the train, maybe waiting outside of a classroom, things like that. And now everything finished. The captain Toad will give me a final summary saying everything is done. All the dev work is complete. So you are looking great. And then a final screenshot. So I explicitly asked the agent always provide me with the screenshot. That is what I'm talking about. I want to save token because that demo finished around 11 p.m. That's the time I want to shut down everything. And we have a control on the VM saying every night everything shut down. Same with my integration service. So I can use more of my Azure resource to build out more stuff next day. OK, so that's end-to-end demo. It's about 7-8 minutes, but it took 2 hours to complete end-to-end. And my only input is the initial scope, what app I want the agent to build, and a few iterations of bugs. OK, so what's next? That's my last slide. So I built everything on Azure VM. If you have been following Microsoft build from Microsoft, we also have a few things now available. We have got the OpenClaw Windows Companion app. That app will be able to run inside a Microsoft execution container, which allows you to control the permission. Because when we're talking about OpenClaw, people are worried about permission security. So let's have a quick look at how that works out. So if you install the companion app, you will have that app, the OpenClaw, as a part of Windows menu. You're able to see how many other claw connect to the instance. You have access of all the details of the claw configuration, very similar to what I showed you earlier in a VM. But this way, it's much easier because it's a part of the app on a local computer. And then you have the chat. You have all the configurations available to you. And if you look at the window, if you open it up, it's very similar to the demo I showed you. You can interact with the agent. It can give you a response. The key thing here is you also have a number of configurations you can do. You can see how many folders are engaged. And importantly, you have a sandbox. So there's a sandbox option. You can explicitly define which folder the agent only have a read permission. It can't touch it. So in this case, we say our desktop, you can only do the read only. You cannot really change a file inside, right? Then, because it is controlled by the execution container, if you ask the agent, you can see a lot of background image on desktop, to delete all the files on my desktop, the OpenClaw will try to delete, but the execution container will block such write action. So in the end, you have a secured folder. the Copilot, the OpenClaw cannot touch. In this case, in the end, I said I want to delete, but it's read-only, so I cannot do it. So that's something you can now use and have a bit of control over your OpenClaw, very different to how I did in the VM. So that's an important thing when you do OpenClaw. You need to think about what is happening, what permission I gave it to the OpenClaw, and keep on building out. I think I'm about time. I think that's all from me. Hope you liked the session. Do I have time for QA?
Daniel will be here all day, so please do look for him if you do have a question. We've got an extra treat. He's here for the rest of the day because he flies back to Sydney tonight. So do look for him. He's here all day with us. So thank you, Daniel.
Thank you. Thanks, everyone. If you want to connect, that's my LinkedIn.